Hello, my name is Michael Martin. I'm a peer tutor for the CNST department, and I'm sponsored by the Office of Student Success. Today we'll be covering a tutorial on routing protocols. Specifically static routes, router RIP, and OSPF. So why do we need routing? We need routing to get from broadcast domain to broadcast domain because routers break up those broadcast domains, so there's different ways to go about that. The most basic way is through static routing. Okay, so it's the most basic form of routing, and in that, every single route needs to be configured by the admin of the network. Okay, so basically that means that routing tables are not shared with the other routers automatically. So, you know, each router needs to know the path to every single other router it needs to communicate with. Okay, so to enable this, all we do is from global config type in IP route, the destination network ID, the subnet mask of that network, and the next hop IP address. Okay, so showing here in the static routing, we have three routers. Okay, router A needs to know about router C, and router C must know about router A. Okay, to be able to communicate. Router B is in the middle, so it knows about both. But if you were to extend this diagram further, router B would need to know whatever else is on the other side of router C and router A. Okay, so on the diagram here it shows router A config in config global config. Okay, so we would type in IP route 172.16.10.0, okay, which is the IP address of which is the subnet for router C between router C and router B. Okay, the subnet mask, which is 255.255.255.0, okay, and then the next hop. Now the next hop for router A is going to be the first interface that it hits on the next router, which is going to be 172.16.20.2. Okay, so going back the other way, if router C needed to talk to router A, okay, you would type in IP route 172.16.20.0, 255.255.255.0, and then the next hop, it would be the interface here on router B. You know, it could be 172.16.10.1 or 2. Okay, it's very basic. It doesn't allow, you know, there's no router table updates, none of that. Everything needs to be configured by the admin. Okay, now going up from there, we go into distant vector routing. Okay, so specifically we're going to talk about router RIP. Okay, now you know, if you break down distance vector, it's how far and in which direction it needs to go. Okay, RIP itself has two versions. Okay, the main difference is that version 2 supports classless subnetting, which is basically variable length subnet masking. It does have a maximum hop count of 15 hops. So router RIP is okay to use in a smaller network that the information doesn't need to travel over, you know, more than 15 routers, and it's easier set up. Now the routing tables are updated every 30 seconds. Okay, so every 30 seconds, each router is going to push out their routing tables on all their active interfaces. Okay, now now if the router doesn't receive a table in 180 seconds, it puts it in a hold down time, or it puts it in a hold down timer. Now if no response is received in 180 seconds, the route is marked as invalid and no information will be sent out that route. Okay, now to set up router RIP is actually fairly easy. Okay, so from global config, all you do is type in router RIP, and then it'll bring you into config router. Okay, so now you're in the area in the router where you can set up the routing protocol. Okay, all you do is type in network, and then the network ID of the network you wish to use for router RIP. Okay, if you need to use version 2, all you do is type in version 2, and it'll enable version 2. Now, you can set up passive interface. Now, this is important because if you don't want your routing tables to be sent out on an interface, like say there's a neighbor router that you don't fully trust, you can set that interface as a passive interface, and it won't send the routing tables out that interface. It can receive them, but it will not send them. Okay. Now, moving on, now we're going to talk about OSPF. Okay, so now OSPF is a link state routing protocol. Okay, now link state routing protocols only update when a change occurs. Okay, so these are aware of the entire network topology, and they don't need to send out the routing tables every 30 seconds. So there's less overhead on the network. Now, OSPF itself supports VLSM, and it has an unlimited hop count. Okay, so you can use this, if you're using classless subnetting, and you can use this on very large networks. It also supports supernetting as well. The routers, like I said, are aware of the entire network topology. Okay, and OSPF uses the SPF algorithm to determine the best route. Okay, so it uses a number of metrics to determine which way it's going to send the information out. Okay. Now, the routers do exchange LSA packets, but it's saying hello, every so often. And it sends those to the designated router or the backup designated router for a given zone. Okay, and zones can contain multiple routers. So to set up OSPF, it's fairly simple. You go from global config, you type in router OSPF, and the process ID. Now the process ID, it's unique to each router, so they don't have to match from router to router. Okay, it can be any arbitrary number from 0 to 65,535. Okay, and then once you type that in, press enter, it takes you into the config router part. And to add a network to your OSPF, you type in network, the network ID, the wildcard mask, and the area, and then the area number. Now, the wildcard mask is basically the opposite of the subnet mask. Okay, so like you see on the screen here, if you have a subnet mask of 255.255.255.240, you're going to have a wildcard mask of 0.0.0.15. Okay, so basically you take each octet and subtract 255 from it. Okay, now in a wildcard mask, 0 means that those bits must match, and 1 means that it doesn't care. Okay, it doesn't matter. It's not going to inspect that. Okay. Now, in order for OSPF to work, there has to always be an active interface for OSPF to function. Now, since your physical interfaces may not always be up, a virtual loopback interface can be configured so that there's greater stability in the routing table. Okay, so it's set that up from global config. You type interface loopback 0, okay, and it brings you into an interface config. And then you type in an IP address, the IP, and the subnet mask, and press enter, and that's it. Okay. So like I said, the loopback forces the router to use that address as the router ID. And since the virtual interface is never going to go down, it creates a more stable routing table. Now, each network ID corresponds to an interface. So inside each area, the area number is the same. So if you look down here on area 26, all the interfaces in that black circle are area 26. Okay, now that one router that's bordering area 0 and area 26, the two lower interfaces are part of area 26. However, the interface that's connecting into area 0 is area 0. Okay, and this is also illustrated from area 34 to area 0. Okay. Now in this illustration, area 0 is simulating a backbone, and a backbone is usually going to have a lot of bandwidth, and it can have a lot of routers in it, so that there's multiple paths to get the information across. So again, area 34, inside the black circle is area 34, and then inside the red circle is area 0. So on that router that borders it, one interface is going to be on area 34 and the other one's going to be on area 0. And that has been a tutorial on routing protocols, static routing, router RIP, and OSPF. Again, my name is Michael Martin. I'm a peer tutor for the CNST department here at TSTC, and I'm sponsored by the Office of Student Success. Thank you.